SAS Programming Challenges in ISS and ISE studies. Now, the first challenge here is the heterogeneous study data structures, which are having different CRFs and the different SDTM versions. Now, imagine you have 12 different studies, individual studies, which the sponsor wants to combine into ISS and ISE study, right? So some studies they might have been conducted 5 years before, or some studies they were conducted 10 years before, or some studies they were conducted just 2 years before. So like say 5 years before there was no SDTM version or the concept, or 10 years before there was nothing, any kind of sort. So in such situations where the different CRFs are designed in a separate structure, and also the SDTM versions are also different. So how do you handle such kind of different database structures, and you all need to combine into one specific structure, either horizontally or vertically, right? So the solution here is to build a study level ETL mapping layer, standardized variable names, formats, visit structure before pooling and document mappings. Now pooling is nothing but you are combining all the 12 studies into one, right? So here it's a pooled kind of study, right? Combination, that's the integration of 12 studies. Now the harmonization and pooling plays a very important strategies when you're working in ISS and ISE study. Now the solution is to build a study level ETL mapping, right? Study level means for each study you might have to prepare a mapping layer, like say for example, if I'm having this visit number and visit day from study A, right, and I'm having this visit label and visit day from study B. So what strategy I would like to apply? So I will try to apply a common variable, that is the visit num for the visit number, and the visit dy as a variable name for combining or pulling into the ISS study, right? So you will have different concepts, like variable names are different, even the formats are different. Then the in formats, the length is very important. Now when you're working with variables into SAS software, imagine the attributes called as formats, length, then the numeric or character, then assigning any specific format label to that, which is a hidden formats. So those are very essential. So first thing is, if there are any hidden formats that are applied, like say you are seeing one, but in the backend it has been assigned one as male and two as female, but now you want male and female to be seen as the data value in specific variable. So that's a hidden format that you see. So this attributes, controlling and keeping a track of each and every mapping layer, for each and every study level. So say for example you have 12 studies. Now you can imagine you need to first build up a very strong document for converting before working on to the ISS study. So when you do this, for example, converting this variable names from study A, and study B is having different visit number and visit day, right? The variable names are different from study A and study B, and when you combine it into a single one, imagine you are just handling only 2 studies. This is an example. Now say for example you have 12 studies, it would be such a tedious and a daunting job. So this mapping layer document, it will help you a lot to get the traceability and to check each and everything as to what you did in which study and how did you map. That means what was the older version, what was the new version, and what was the proposed version that I'm using and I'm implementing into the ISS and ISE study. So this kind of pooling strategies, especially the mapping layer document mappings, will help you a lot in keeping the homogeneous study data structures in ISS and ISS study, irrespective of having the heterogeneous data structures across all 12 individual studies. Number 2, inconsistent treatment / treatment arm labels across studies. Now, say for example, you have 12 different studies, individual studies, you are combining into one ISS and ISE study. So it could be possible the treatment arms and the treatment labels are completely different. Like, so how do you handle that? So the very first thing is your solution is to create a canonical treatment lookup table. So again, it comes back to your mapping and documentation. So you have this study plus arm. So you standardize into treatment which has taken actually the number or the arm code, or you can write arm and apply during integration. Integration is nothing but combining all the 12 individual studies into one, which is ISS and ISE study. Now say for example, I'm trying to map the study A, arm is high dose, right, where the D is capital and the H is capital, so it is in the proper case, and the study B arm is nothing but HD. Now you don't know what HD stands, right? Whenever a common layman's person will look, so you do not know what does it stand for. So in study A it is high dose, whereas in study B it is HD. So again you see it's an inconsistent labels that has been assigned to the treatment arm. So how do you handle this? So in study A, I will use high dose, and study B also I will use high dose, and the arm code will be HD in study A, and also in study B I will use arm code as HD. Now this arm and arm code will reflect where? It will reflect in the actual ISS and ISE data structure, right? In study A and study B the values will remain same, but when you're combining into ISS and ISS study, you need to enter arm as high dose and arm code as HD for even study A and study B records when you're combining into vertically, right? So these are the strategies that you might need to come across, and these are the only solutions that you need to make for making the mapping layers and the documentation and the lookup table. So document as much as you can when you're working in ISS and ISS study for each and every study. That will help you a lot, like in going back and having a traceability as to what was done earlier and what are we doing now. Number three is a different baseline definitions, that is baseline windows. Now you will see the 12 individual studies, they are having different definitions, their baseline windows are different. Some studies were conducted in efficacy, some study was having the PK study, like the phase 1 related study. Now you are combining phase 1 and phase 4. Now you can understand the phase 1 is your PK related study, pharmacokinetic and pharmacodynamic study. Now phase 4 is your post-marketing study. So in those kind of scenarios, your baseline definitions will be different, your baseline window periods will be different. So how do you handle such kind of a challenge? So the solution here is to implement study specific baseline selection logic and a baseline derivation macro, and then flag and harmonize baselines for pooled analysis. So say for example, I have this 12 individual studies, right? I will first find out what was the baseline definition in each and every study. Now once that is confirmed, I will try to harmonize, or I will try to come to a basic definition that will match, or that is somewhat equal in most of the 12 individual studies nearby, right? So I have to harmonize and I have to pool that analysis so that I get the right results. And in ISS and ISS study, you will be using the pooled baseline definition, right? Now to achieve that baseline definition, you have achieved that through theoretically, right? Now practically, how do you achieve that? Now practically you can create your own macro. Your baseline window periods are different, right? So you can consider those whatever formula that was used in study 1 2 3 4 5 6 7 8 9 10 11 12, whichever the 12 individual studies which are there. So those formulas you can use and you can combine that into one macro. So like say for example, if it is study A, then use this. If it is study B, then use this. If it is study C, then it is use this. So blah blah blah, you can write those conditional statements in specific macro. You can create your even your own macro so that your life becomes much easier. So in that way you can come up with a concrete, common baseline definition that can be used in ISS and ISE study, irrespective of having 12 individual baseline definitions. Now, say for example, BL is equal to some baseline value from last pre-dose measure within say -28 to 0 days for an oncology study. So say I'm having two studies, which is oncology and a PK study. So in oncology, the baseline period, window period is -28 to 0. So -28 is nothing but the patients or the subjects, they will be screened 28 days before. They will undergo certain process of medically, and then at the day 0 they will be checked in, right? So before consuming that particular treatment or the medicine, that is my pre-dose measure value, right? So whichever was your last pre-dose measure is nothing but the baseline value. But when you come back to the PK study, which is a pharmacokinetic study related to phase 1, so in there your window period will be shortened. It will be -14 to 0. So 14 days was gone under the screening period for the phase 1 related patients. So these scenarios you will always see when you will compare the phase 1 and the phase 3 or phase 4 related studies. So what you can do is you can store those baseline definitions and the methods that was used in BL underscore method for traceability, right? So these are the only ways. The only thing is you pooled, you harmonize, you map, and you come up with proper documentation. Number 4, patient identifier collisions and duplicate subjects across studies. Now, you will see in most of the 12 studies, the patient numbers are same, and in there could be across duplicate subjects across studies, right? So how do you handle this specific challenge? Now the solution here is to create a globally unique subject key. Like I said in earlier videos also, you can combine with study ID, because study ID is going to be unique for all the 12 individual studies, right? So you can combine that with the subject ID or an hashed global ID. Now global ID you can create in discussion with the sponsor, and you can take their approval, and you can use that particular global ID to identify the each and every unique record, and check for any cross study duplicates with demographic match rules, right? So if you feel that there might be some duplicate records which was done in studies that were 5 years before, so even you can cross check those duplicate records as well. So say for example, here is detect a subject ID is equal to 001. It exists in study A, and in study B also you will have a subject ID as 001. So how do you resolve this kind of patient identifier collisions and duplicates, right? So when you combine the specific records vertically, you will see that 001 is occurring twice. Two records are there, but those two records are different. One is from study A and the another is from study B. So you can resolve that by using a unique subject ID new variable. You concatenate this subject ID 001 with this study A, right? And so you will have a unique record. So now your two records are unique and they are not duplicate once you create this new variable unique subject ID, and flag potential true duplicates for medical review. So even after assigning this new variable called as a unique subject ID, you're concatenating study ID and subject number, you still feel there are more potential true duplicates, like even after assigning, then you can raise those duplicate records with the medical review. Believe me, working on ISS and ISE study is not that easy. Even if you have 2 to 3 studies, you will still need lot of mapping, lot of documentation, lot of patience, and lot of precision and attention. Now, another challenge, it could be the polling adverse events, which is the MADRA coding differences or the seriousness flags and the onset rules. Now, what are the MADRA coding differences? Now, how do you identify these differences? The differences you identify based on the version numbers. Like say in 12 individual studies, in 6 studies there was one specific version number, say 22 was used, whereas in another study, like say another 6 studies, were latest version, which is version 25 was used. So those kind of differences you will see on the basis of the version of the software, which is of the medra. Now another challenge could be the seriousness flags. Like say in some studies the serious is highlighted as Y, and if the adverse event is not serious, then it is left as blank. In another study the seriousness flag is highlighted as yes, that is YES, right? And if the seriousness is not present in that specific adverse event, then it is presented as NO, that is no. It's like say for example in some studies the seriousness flag is highlighted as 1 if the adverse event is serious, and if it is not, then it is highlighted as 0. Now such kind of challenges you will see in multiple studies. Now the onset rules. The onset rules relates to the treatment emergent adverse event events, right? So say the baseline definition of identifying a specific event as an adverse event, that rule itself is not consistent across 12 individual studies. So how do you handle so much of differences and most of the challenges? Now in ISS and ISE study, most of the challenges that you will see from this slide in all of the studies, like say especially where the adverse events are concerned, the rules and the seriousness. So this is a very important factor because you are considering into the safety parameter, right, for ISS and ISE study. So the solution here is to standardize medra version, so you can use as the latest version in all the 12 individual studies, right? So what you can do is you need to map preferred terms. You might need to harmonize the treatment emergent AE, serious AE definition rules in a central macro with study level parameters. Now, before harmonizing a specific definitions for treatment emergent AEs and serious adverse event rules, first you need to understand the rule of each and every 12 individual studies. Okay, write it down in a piece of paper. Try to make a Excel sheet and see what are the different definitions. Then you can come up with a common harmonized rule, and that you can convert it into a central macro with study level parameters. So say for example if it is study A and if it is this definition, then you assign that particular record as a treatment emergent AE in ISS and ISE study database, right? So such kind of rules and regulations and macros also, it will help you a lot by making your own rules when you're playing with the SAS programming, right? So example is like say remap preferred terms coded in medra from version 24 to 25 and rederive the start date, end date and AE seriousness consistently across studies. So say your format of character, end date and start date, they are format is different, right? DDMMYY, whereas in some study it is MMDDYY, and in another studies it is say YYMMDD. Now it is a very tedious job to check each and every study and see their formats and then consistently put across the constant and the similar rules for the converting the dates, right? So consistency is very essential when you are working in ISS and ISC study. Number 6 is your exposure calculation differences, dosing schedules and missing stop dates. Now this could be another challenge when you work in ISS and ISC study, where you will see the calculation of exposure is different, how the stop dates they were handled in the missing related solutions, right? So the solution here is to implement an exposure macro that handles study specific dosing rules, imputes missing stop dates conservatively, and outputs consistent say exposure treatment dose, the character start date, the character end date and the exposure days, right? Like say for example how many days the subject or the patient was exposed to that particular treatment, right? So for example you can create an intermediate dosing study, compute the exposure as sum of dosing intervals for missing stop date, assume the last known dose and the protocol specified interval. So when you're working with the exposure, again this is very important factor because it relates to the dosing of the treatment, right? If you do a big blunder in this specific domain, it really affects a lot, like it gives the wrong kind of information. So you have to work on this exposure related domains and records very accurately here. So your calculations related to your exposure is very essential. So you need to ensure that the stop dates are always present for most of the studies. So you can create such macros, and you can identify, and you can create your own system and harmonized and the pooled based on the availability of data. Number 7 is your lab result, unit and reference range inconsistency. Now you will always see, like when you have the 12 individual studies, you are trying to combine into one individual study. The lab units are not same, the reference ranges are different, the vendors are different. So how do you harmonize these? So the solution here is to normalize units with conversion factors to a standard unit, and store the original unit as well as the conversion provenance, and harmonize lab reference ranges by lab, or use centralized normal ranges. So whenever you see the units are in normal and you need the standard unit, right? So what you need to do is you need to get the conversion factors of that specific laboratory test. Now when you say laboratory test, there are so many: hematology, biochemistry, then urinary analysis, and there are so many other laboratory tests. So for each and every lab test, you need to have a conversion factor from the original unit to the standard unit. Now you will also see some of the unit where you have never worked on, right? So it becomes very challenging. So you can ask to your medical team, whosoever is a doctor, you can ask to your lab vendor, or you can ask to any sponsor. If the doctors and the vendors, if they don't have any solution, or if they don't know the conversion factor, then the last option is to ask to sponsor, so that they can help you in getting your conversion factor. So all these conversion factors, again it's very essential to do the document mapping, and the what you call whatever the excel sheet you can make, like if it is in this unit I have converted. So each and every study, your mapping and documentation and the harmonization is very essential. So you would say, for example, I have to convert glucose from mg per dl to millimole per liter using factor, the specific factor, right? So what I'll do is, in ISS and ISE study, I will keep both. I will keep the original values also, and I will also keep the standardized value. So when I see the structure, I will come to know in ISS study that this was my original, which is reflecting from that study A, and this is my conversion factor, which I'm going to use in my specific, like your what you call the analysis into table listings and figures. So it becomes very essential to keep this kind of values. Number 8 is your deriving common analysis flags. Say for example, I have this treatment emergent AEs flags and the responder flag. So now there will be analysis flags. You need to ensure that their definitions are same. If it is not same, then you need to ensure that it should be same and it should be harmonized, right? So whenever you're deriving such flags from multiple studies into one, then the solution is to use centralized, well documented macro library that accepts certain parameters, like say start date, baseline method, to derive flags consistently. Now again, the baseline method was different, right, when individual studies, right? But the flags, whatever that you're using in the ISS and ISA study, the definition is going to be new. It's going to be the harmonized one, right? So your flags also somewhat here and there it will change. It will not be remain the same. Not 99.9%, it should be same whenever you're deriving the common analysis flags. So you can create your own macro library, and you can derive those flags which are consistent and presented in ISS and ISE database. So say for example, I'm creating this micro derive underscore treatment emergent AE flag. My insert data set is AE, the demographic, and the output is this specific new data set. So you can set this duration, AE sequence, and the AE OTR uniformly across studies. So this is again one challenge, like to build up the analysis flags. Again, your documentation, mapping, harmonization, and pooling, it will help you a lot. So say number 9 is time to event pooling, sensorizing rules and event definitions differ. Now say I have 12 individual studies. In some of the studies the censoring rules were different. Like say censored was assigned as 0 and uncensored was assigned as 1. Now in another study it was vice versa. Censored was assigned as 1 and the uncensored was assigned as 0. So in those kind of scenarios it becomes very difficult and challenging to handle such kind of scenarios. So your pooling and the harmonization is very essential. So you can define canonical event censoring rules in writing, implement a reusable time to event macro that accepts study level censoring parameters and the outputs with is time and the event, right? So say for example, when I'm using this progression free survival, set event is equal to progression or death, right? So event is my whether the disease has progressed or it has given as the event as death, right? So that is my event. So censor at the last tumor assessment date if there is no event. So event is either the disease has worsened, which is progressed, or it has resulted in death, right? So that is my especially my event. So those kind of events you can censor, and those events which are not present, like say last tumor assessment date, if there was no event, right? So this macro applies consistently. So whenever you are using this censoring rules, event definitions, so first you need to identify in all the 12 studies whatever the definitions that were used, the rules, and then you can come up with the pooling strategy, and then you can create your macros and you can set into your ISS and ISE study. Number 10 is your missing and inconsistent metadata and insufficient provenance traceability. Now it so happens like the metadata is not consistent, and that gives you the insufficient in traceability of data. So I have 12 individual studies and the data is not up to the mark, and I'm not able to get the traceability. So the solution is to generate and maintain automated audit logs, mapping documents, like I said, dataset lineage tables, and version code with embedded whatever proven variables that you are using. For example, source study was this specific study, origin variable was this, whereas I have renamed to a new variable. The mapping nodes, so whatever nodes that you are doing for mapping this variable into another variable, so those kind of notes that will help you. So say for example, in each pooled variable includes src underscore study, so where I have handled a study A, right? So src variable is your lab originals, and mapping is converted this to this. So these are the examples which I'm giving, right? So this was my study A, was my source study, and this was my original variable which I took it from src underscore variable, and mapping note is nothing but converted from this unit to this on so and so date. So this is for traceability. So likewise you need to create all these kind of variables, and you also need to mention that you try to automate the audit so that you get the traceability of each and every variable as to all the variables that are present in all the 12 individual studies. All those variables and their values, they were mapped exactly and properly into one ISS and ISE study with proper documentation, so that even if you leave the organization, if a new person is coming, that person will be able to understand based on the traceability. Like say for example, what was done earlier what are we doing now and what are we going to actually implement in the specific database and the programming. So those kind of traceability will help you a lot in overcoming the SAS programming challenges in ISS and ISE studies. Please like, share and subscribe. Leave a feedback comment mentioning any topic that you want me to make a video. Looking forward for a positive response. Thanks for watching. Please like, share and subscribe. Leave a feedback comment. Many thanks for your support and having great connection.